In this lesson, we will introduce briefly the process statement that we will see in detail in the next lesson. A process statement is a concurrent statement itself. It has a sensitivity list, a declarative part, and a sequential statement. The process statement is very similar to the classical programming languages. The code inside the process statement is executed sequentially. The process statement is declared in the concurrent section of the architecture. Two different processes are executed concurrently. The declaration process statement is an optional process label. You can avoid using label. I suggest labeling all processes you use. In fact, the code will be clear and it will be simple to arrange a simulation environment. A keyword process followed by a sensitivity list. The process declarative section, in this section you can declare variable and constant that will be visible only inside the process. The keyword begin, and then the sequential statement section. The statement is closed with the keyword end process, followed by the process label. We will address the process statement in the next lessons. Here there is a simple example of the AND or TO entity implemented with the process. The entity declaration is the same as in the previous example. In fact, the interfaces versus the external world are identical. ABDE input port, G output port. The architecture declaration section is empty. We don't need an internal signal declaration. The circuit is implemented using a process, the process and/or. In the process sensitivity list are declared all signals which the process is sensitive to. In fact, the process is evaluated anytime a transaction is scheduled on the signal A, B, D, and E that are input port of the entity and/or. The process drives the entity output port G. The driver concept is fundamental in vhdl. You shall deeply understand this concept, since it's the principal reason of error in the hardware implementation of a vhdl code.